So yeah, how is everyone doing? You've been having a good day so far at NDC? Yes. This is, I love NDC. This is my second NDC Oslo. It looks just as incredible as it did last year. I'm very excited to be back. Lots of cool sponsors, amazing food. I am going to spend the next 2 days standing by the poke bowl stand and just shoveling into my mouth, I think. And of course, amazing speakers. I'm very honored that anyone's come to my talk when there are so many other great speakers in the same slot. I hope to make it worth your while. We are coming up on 21 minutes past, at which point I'll properly kick off. Right. Thank you all so much for being here. My name is Eli, and I am here to talk to you today about how we talk to each other. So, this talk is about communication, and a lot of what we do as people who design and build and maintain software is communicating either with other people or directly with computers. Has anyone ever had the problem where you're reviewing a PR and one person is saying, we could do this in a beautiful, elegant one-liner that's really unreadable, and somebody else is saying, actually, we could split this out into a multi-line statement, and it would be a lot more readable, but it wouldn't be as neat, or it wouldn't be sort of as satisfying. So does that sound familiar to anyone? Like a couple of hands, yeah. Has anyone ever been in the situation where a requirement has come in from a product owner that makes complete sense for the real world and the problems that your software is solving, but would mean that you had to rewrite your software from scratch? Something like, we need our users to be able to change their email address, but you use the email address as the primary key. Does that sound familiar? So both of these are examples of miscommunication, or they are problems that relate to communication. And as we go through this talk, I'll explain why. And I'm going to take you through some rigorous frameworks from some philosophers from history that can teach us a little bit about how to think about communication and how to get better at it. So, here's what I think is happening when people communicate with each other. Here are two people, without loss of generality, me and you, and I have an idea in my head. I want to convey this idea to you, so I say something or do something. I make some gestures, or I write some words using a keyboard or pen and paper, or I say something. As a result of this action that I've taken, you perceive something. You hear the words I speak, read the words I write, or see the gesture that I've made. And as a result of your perception of this action, you get an idea in your head. And this is the basic model that I'm going to use to illustrate the ideas throughout this talk. Of course, it can get far more complicated than this, right? We could, in the middle of this flow, turn those words or those actions or those gestures into something that gets encoded digitally and sent over the internet or written down on paper. And there's all sorts of errors of transmission that can happen in that stage. But for now, we'll focus on this sort of more basic case. One of the things I like about this model is that it makes it very clear that in between the part where I have an idea and the part where I say something, there's a translation layer here. The pink light bulb and the pink gesture, they're not the same thing. So there's for every person, there's this sort of internal translation layer that lets us know how to turn ideas, concepts, into gestures of communication, right? There are multiple ways, perhaps, to express one concept. This is something I learned when I was doing maths tutoring during my degree. I was trying to explain logarithms to a student about 17 or 18 years old. And the way that I conceived of them, that they made sense in my brain, I couldn't find a way to convey that so that she could have that light bulb moment. I had to try lots of different ways to express this concept. Similarly, you might have one way of expressing something that could have multiple meanings. The word run in English has something like over 600 dictionary definitions. I'm going for a run. I'm running software. My nose is running, you know? So we've got these ideas, and we have things that we use to express ideas. And this is a many-to-many relationship. This means that communication is really hard and confusing. So how can we understand the relationship between these two things? It's time for us to meet our first philosopher of the day. This is Ferdinand de Saussure. And he was basically one of the founders of modern linguistics. Do we have any people who are really into linguistics in the room? Yeah, a handful, cool. going to be talking about linguists today. Ferdinand Saussure, the thing that he did that we're particularly interested in today was that he basically founded the modern field of semiotics, one of the two major founders of semiotics. He called it semiology, we now call it semiotics. It means the study of signs. And signs might make you think of road signs, visual signs, but in the world of semiotics, a sign is anything that is used as a tool of communication, anything that is used in order to communicate. Words are signs. Gestures such as like this for I love you in British Sign Language, that's a sign as well. And the thing that Saussure said that was kind of groundbreaking for his time was he said, okay, a sign has two components, and they are the light bulb and the gesture, right? He said, okay, we've got something that lives in our heads, and when we use a sign to try and convey it, this is the thing that's being signified. And when we do something to try and signify an idea, that's called a signifier. Now, in the interests of me not fumbling my words and having a better chance of the two light bulbs in our heads matching as closely as possible, I'm not going to say signified, I'm going to say concept. So we've got concepts and we have signifiers, and we use signifiers to try and communicate concepts. And Saussure said something that was groundbreaking for his time. He said that these two things don't intrinsically have to have anything to do with each other. This was, people thought at the time that the words we used were somehow a sort of metaphysical reflection, expression of the concepts that they referred to. But that's not true, and I can give you an example to show. Here's an animal, and in Egyptian, this animal is called a mao. And if you've ever met one of these animals, you'll probably understand why. But in English, it's a cat. Why? I don't actually know. I don't know the etymology of the word, but on the face of it, there's no reason that this sequence of sounds should refer to this animal. But it does. We all understand that it does. The sign, cat, and the concept, that animal, are two different things, but we understand that they're connected. So when we come back to this model where you've got ideas in your head and things that you say, things that you perceive, and we come back to the idea that we've got this translation layer that lets us translate between concepts and signifiers, and that forms the basis of our ability to communicate. Another thing I like about this model is that it makes it clear that the ideas in the people's heads, right? The pink idea that I have in my head, the contents of this talk, and the blue light bulb that you have in your heads at the end of this talk, they aren't the same thing. They can't even be directly compared because of those internal translation layers. All we have are best guesses and attempts to signify what we mean through these potentially imprecise signifiers. These two things are not the same, and we can never know if they're the same. Is the blue sky that you see the same blue sky that I see? So we have concepts and signifiers, and our ability to link between these two gives us the ability to communicate concepts between my head and your head. How can we understand the relationship between them? This forms the basis of our ability to communicate. Well, Saussure had an answer for this too. He said that when somebody speaks, when somebody communicates, it goes like this. There's a person with an idea in their head, and as a result of trying to communicate that idea, they say something or do something. Familiar so far, right? He called this parole, an act of speech. He was French, these are French words, parole. And the person knows how to make that act of speech to try and communicate because they have an understanding of something he called langue. And this is what linguists study, right? This is the shared understanding of language, of a human language, for without loss of generality, that allows us to make that translation between concept and signifier. And we all share this understanding, but it is also entirely constructed and lives entirely within our collective heads. And this is really interesting to linguists, because how does this thing grow? Well, what Saussure said, and again, this was groundbreaking for his time, he said that acts of speech actually contribute back to the overarching language, right? We know this to be true because we have, slang. And when you use a word to mean something, if you gain critical mass within the speakers of that language, it becomes an accepted part of that language, and it becomes a way that somebody can communicate a concept. and Saussure called this a speech circuit. So when we think about language and being able to translate between concepts and signifiers, we have to think about this thing, the langue. We have to understand, where does this come from? How do we know how to use it? And this is what leads us on to meeting our second philosopher of the day. This is Ludwig Wittgenstein. Any Wittgenstein fans in the audience? Yep, a couple. To me, he was the philosopher. He did everything, like maths, ethics, logic, language in particular. One of the most influential philosophers of all time, according to a lot of people. I like a lot of what he said. And one of the things that he did that we care about in particular today is that he came up with the concept of language games, for which this talk is named. And what Wittgenstein said was that language is a game like games of skill or chance or athleticism. And language has rules. And every time you make an act of speech, parole, you can be understood to be making a move as part of the game of language. And that when people share an understanding of the rules of the game, they are able to play together, which is using language to participate and using language to communicate. So the other thing that matters, and again, this was groundbreaking for his time, is he said that in different games, different rules can apply. The rules of a language game give us the means to translate those concepts in our head into signifiers that other people can perceive. It's a pretty abstract concept, and he mostly used analogy to try and explain it rather than give a direct explanation. So I will do the same. Let's say we have two attendees of this conference. Let's call them Tibbs and Espen, and they're building some Lego together, right? And they have a Lego set that is comprised of a bunch of 3 different kinds of Lego elements shown on the screen above. And Tibbs is building, and Espen is handing Tibbs pieces. And Tibbs says, brick. And Espen hands them one of these pieces. And then Tibbs says, plate. And Espen hands them one of these pieces. Then Tibbs says, jumper. And Espen hands them one of these pieces. They're playing a very basic language game in which the word jumper means hand me one, and exactly one of that style of Lego element. Now, it's worth noting that the rules of this language game are inefficient. Pink, the color, has 1 fewer syllable than jumper. Pink, white, and blue would have been more efficient ways of communicating the same information, right? But Tibbs and Espen are both big Lego nerds, and they want to use the official Lego terminology to describe the elements that they're talking about. Language games aren't necessarily, especially with natural human language, aren't always the most optimal, the most efficient. There's human quirks in there. So we understand that language is a game, and it has rules, and that if we understand the rules to be the same thing, we can play a game together, and that will be communication. So if language has rules, what does it look like when we break the rules? Here's a sentence, and I'll give you a moment to look at it. Can anyone tell me what this means? It doesn't mean anything. This is an example of something that's called a comparative illusion, and it's a bit like the linguistic equivalent of one of those Escher staircases that loops back around on itself because of the perspective. Each part of this sentence looks like perfectly fine English, but when you look at it as a whole, it doesn't mean anything. There is technically a grammar error in here, and it's to do with the fact that you're comparing a number, more people, to a bool, a truth value. Have I been to Berlin? But it's a very subtle grammar error, and it's one that most native English speakers wouldn't know how to describe. I certainly didn't until I looked at the Wikipedia page for this. So this is an example of breaking the rules of the English language, and what it results in is something that doesn't communicate any information. It's a failure of communication. Here's another sentence. Does anyone want to tell me what this one means? I have a pointy baby. She's a cat. I have a cat. This means I need to trim my cat's claws. I say this all the time in my household. She's the baby. She's an indoor cat. She isn't wearing down her claws on concrete or anything. So sometimes her claws get long. She becomes sharp. So we need to unsharpen her. So we need to unsharpen the baby. And like this Berlin sentence, this might not seem to make sense. But in the context of my household, it does, because like with any game of skill or athleticism or chance, you have your basic rules, the rules of English, and you can also have house rules, additional rules that go on above and beyond the basic rules and allow you to make different kinds of moves that make sense for your context. And this is the thing that Wittgenstein really was trying to get at with his idea of language games. And I think it's very similar to what Saussure was saying. Context sets the rules for a language game. Language only makes sense in context. So, for example, the word water could mean a lot of different things. It could mean, I am absolutely dying of thirst, please let me take a drink. It could mean you're cycling and somebody's about to go into a pond. It could mean any manner of things. It could be somebody, expressing why they didn't like Generation 3 of Pokemon. Too much water. 7 out of 10 or whatever it was. Context is the thing that gives language meaning. And like with Saussure's ideas that the signifier and the concept didn't have to be related, this was pretty controversial and groundbreaking for his time. People thought, they didn't really have this idea that different things meant things and different things in context. There was, again, this kind of idea of words and language having some sort of metaphysical, real meaning that wasn't just simply contextual. But Wittgenstein says, no, it is all contextual. And the more context we share with somebody, the better we're able to communicate. The less context we share with somebody, the less likely it is that we're going to have a lot of rules in common and be able to use those rules. Our language games are going to be much more limited. So what does it look like if we have to communicate with people with whom we share very little context? There are some people whose entire job is to figure this out. Does anyone recognize this sentence? Yep, Tibbs is getting it all, and you as well. So there are some people, one of the things that humanity does is we build things and we do science and we make things. And we've caused lots and lots of problems for ourselves with this over the course of human civilization. And one of the problems that we've caused is nuclear waste. Nuclear power, good, great, actually, but it does result in waste that is dangerous now and will continue to be dangerous for 10, 20,000 of years. The half-life of some of these waste products is that long. And when we think about 10 or 20,000 years, that is longer than any one human civilization has lasted. Human languages come and go much, much faster than that. They evolve, they die out, so on and so forth. And there is an institute for the long-term storage of nuclear waste, and they have a mandate to try and figure out, if we bury some nuclear waste, how can we prevent people in 15,000 years' time from going to dig it up? Because it will still be harmful to them. And what they've come up with a lot of stuff, but the most famous of them is this series of messages that are meant to embody the sort of, these are meant to represent concepts, and we have to try and find signifiers that are going to make sense to people in the future. And the concepts range from very general, and then they start becoming more and more specific. So these are some of them. What is here is dangerous and repulsive to us. This message is a warning about danger. These messages are some of the most metal stuff. It's so cool. The danger is in a particular location. It increases towards a center. The center of danger is here, of a particular size and shape and below us. The danger is to the body, and it can kill. The form of the danger is an emanation of energy. And you can see that we're going from sort of more broad, general, generic things down to more specific, like talking about where it is and what it is. So we're going from ideas that are easier to convey because they require less context to more specific. Because the more specific an idea is, the more context you need in order to share it. This is a sign that this institute has come up with. It is called ISO 21482-2007, made in 2007. And the idea is that this sign will be displayed at any nuclear waste storage sites. And if you look at each individual element, there's sort of three things going on in this picture. We can look at each element and see why or why not it might be effective as a method of communication. So one of the things we can assume about people in about 10 to 20,000 years' time is that they will look quite similar to us, broadly. That's not enough time to evolve more legs or anything. I mean, I guess depending on how close you are to the nuclear waste. But we can broadly assume that people will look quite similar to us. So if you think about a skull, generally, human civilizations have buried their dead, pretty much like some of the earliest sort of records that we have and remains that we have show that people have been burying their dead for a long, long time. So you don't see a skull unless something's gone very, very wrong. This is something we can probably assume to still have a universal meaning of bad. Something's bad here. You do not want to be here, you do not want to see a skull, this is bad. We can also assume, again, that people are going to look quite similar to us. So these symbols are fairly likely to still be interpreted as like, a person in motion, This one is the one that's really difficult because nuclear radiation, ionizing radiation, is a really difficult concept to convey. I mean, honestly, even to someone without a physics background, you try and convey that, like, what is nuclear radiation? Is it real? How can you tell if it's around you to somebody who hasn't got sort of up until about 16 years old been learning physics? That's really hard. And then when we try and think about conveying it to people 15,000 years in the future, we have no idea if they'll even have an idea of what this concept is. So this one, I think, has the highest chance of not being parsed by the audience in the way that it's meant to, but I think that's an intrinsic difficulty. And on the theme of things used to convey meaning, potentially having multiple meanings, this sign could mean danger is here, ionizing radiation is here, leave, there is danger. But it could also mean when snakes come out of the ceiling fan, run away from the pirates. And that's something that I really want to try and get across, is that when we communicate with other people, all we have are best guesses. We can never actually be completely certain, like logically certain, that we have successfully communicated a concept. We can't compare the blue and the pink light bulbs directly. We can't know that we have communicated adequately. That's scary. Communication is hard. Right, with that in mind, we come back to this model of people trying to communicate concepts with each other. And this is well and good, and this is something that we have to do in our job as software developers. But part of our job is also talking to computers. When we think about the idea of talking to a computer, a lot of the concepts that I've just been talking about don't seem to apply. I mean, a computer has no interiority. It doesn't have concepts and signifiers and so on. It takes input and it executes on that input. So what does it mean to talk to a computer? Well, we build language. We start with machine code and we add layers of abstraction and syntactic sugar until we get to something that can reasonably be called a language. We teach the machine what open curly braces and if and when mean. A programming language is the set of rules for a language game that we play with a computer. That follows pretty naturally, and I think it's really cool. But above and beyond that, what we do as engineers who write software in programming languages is building up house rules that we play with our computer. Like how in my household I can talk about unsharpening babies. Within your software, you can talk about specific concepts using language that you've chosen to convey concepts to your computer in a way that makes sense for your context. Writing software adds rules to the language game that you play with your computer. It allows you to communicate more efficiently without repeating yourself as much. So when we write code, this is what's going on. One person alone at their computer writing some code, building up a language game that they play with their computer in order to communicate things that they want done. And this side of the equation is pretty much a solved problem. If I'm writing Python code and I know that it's in CPython, I can actually look at what that code compiles to. I can go all the way down the stack and see actually what is being executed on my machine. And this side of the equation is get better at writing code. Do your HackerRank, your leak code, your code cutters, all of that stuff. Just get good. One thing that I do want to briefly mention, and my one mention of AI in this talk, is that when you do prompt engineering, it's qualitatively different than coding because you've added a black box back into this side of the equation, right? I can't write something into ChatGPT and follow the chain of execution all the way down the stack like I can with writing CPython. So that, I think, is something that's genuinely qualitatively different about prompt engineering versus coding. Really interesting. I'm making no moral, I don't think that's a good or a bad thing. I think it's cool, I think it's interesting. And not many people are talking about it that much. But anyway, we come back to this scenario. And this is what happens when you write code, right? But when you're a software engineer, what actually happens is this. There's you, and you have an idea of what you want the computer to do, and you write some code, and that executes on the computer. But there's also the rest of your team who are all doing the same thing. And when you work on a team, you have things like meetings, and Jira tickets, and documentation, and water cooler chat. And these are all methods of communication with other people where things I've been talking about very obviously apply, like, language games and so on and so forth. But that's not the only way that we communicate with other people on our team. The path up top, that is also a channel of communication. When we write code, we are communicating with other people on our team as well as the computer. My good friend David Whitney has a talk where he has a quote where it's code is literature that is also executable by a machine. Primarily, code is going to be read more than it is written. And when we write code, we need to be mindful that we're not just building up language games with a computer, but we're building them in order to be used by other people as well. And this is where a lot of clean code stuff comes in. And what happens when you're on a software team and you're trying to work together to solve a common problem as efficiently and as clearly as possible? Is something that's actually been studied by our third linguist of the day. I mean, not directly, but he studied very similar things, or our third philosopher. And this is someone called Paul Grice. He was a British philosopher of language. And what he studied, one of the many things he studied, were systems where people were earnestly, in good faith, trying to communicate with each other in order to reach a common goal. And he described what he saw there as the cooperative principle. He noticed 4 trends, four themes coming up again and again in these kinds of communications. And these are things that he noticed, but he also phrased them as imperatives, like you should do this. But it's worth noting that these are things that he noticed coming up organically again and again. And there were 4 of them. Grice's maxims is also how they're known, and they are these. The maxim of quantity. He noticed that in cooperative communication systems, people are often, they need to be as informative as required, but no more. Don't info dump, but don't leave things out. So, if someone asks you for a specific piece of information, give them that specific piece of information, but you don't necessarily need to include wider context. The maxim of truth. People are truthful when they're communicating cooperatively. This is why a lot of communication that people do is not necessarily cooperative. I mean, we lie, of course, but we also tell jokes where a lot of humor relies on leading somebody to make an assumption by potentially omitting information and violating the maxim of quantity, and then subverting that expectation, or outright telling lies for humorous effect or something. So jokes and deception are not part of this system. They're not examples of communication that's cooperative. But when you're communicating cooperatively, you should be truthful. There are caveats to this. As I've said, I can never truly know what's in another person's head, but if somebody has told me that they have an opinion, it's fair for me to treat that as something that I know. The maxim of relevance, obviously quite related to the maxim of quantity, but let's say that we've got Tibbs and Espen who are playing their game with Lego, and Tibbs says jumper, and Espen hands them both a jumper and a brick. The brick isn't relevant. It's violated the rules of the language game, and it's also violated this Grice's maxim. So if somebody has asked you something, you tell them the answer to that question, but you don't include information that isn't relevant. It's inefficient. And the last one is the one that I think is really interesting, because it's the maxim of clarity, and this is the one that involves empathy, because it's about framing your communications in a way that is most likely to be comprehensible to the person with whom you're speaking. It's about using words that are going to be easy to understand. I know that, I'm a native English speaker. I use a lot of thesaurus words. I really do try to make sure that when I use thesaurus words, I'm using them because they are the correct, most specific word for that situation and not just to make myself sound smart. The maxim of clarity is the most nebulous one of all of these, and it's the hardest to tell when it's being broken. And there's one of the things I love about this is I mentioned that he framed all of these, as well as sort of these maxims, he gave imperative names to them. So maxim of quantity, be informative. The maxim of truth, be truthful. Maxim of relevance, be relevant. But for the maxim of clarity, he didn't say be clear. He said be perspicuous. Has anyone ever heard that word before? Tibbs has had it again. I hadn't before I did the research for this talk. I knew there were the 4 maxims, I knew what they were, but I didn't know that was how he phrased it. What a beautiful violation of the exact maxim he's talking about. Be perspicuous. It means to be something that's able to be seen through, something that's literally clear, something that you can see right through it, you can comprehend it. I believe perspex, the kind of clear glass type thing, comes from the same root. So if you're ever in an icebreaker type thing and you don't know what to say about yourself, just say, I'm perspicuous. Ridiculous word. So we have these maxims that Grice identified, these trends that Grice identified as being hallmarks of good cooperative communication. And this is a talk about tech, so I'm going to talk about how these can each relate to code. We get a lot of clean code stuff directly from these if we want to look at it that way. The maxim of quantity is things like making sure that all your data is present in your code, but you're not including extraneous data in data structures that you use. Maxim of truth, check your assumptions, make sure that the data you think is there is actually there, and do good testing and so on. The maxim of relevance, factor out functions into things that do one thing well and don't have big mega functions with lots and lots of stuff going on, lots of stuff that's not relevant to everything that's going on in that function. But the really interesting one to me here, when we talk about code and writing software, is the maxim of clarity. What does it mean to communicate clearly and use the right words for a situation when we write software? Well, we should be thinking about what it is that we're trying to communicate to the computer. And when we're writing software, usually what we're doing is we're trying to communicate some kind of real-world problem to the computer. We have users and we want to solve problems for them. And we need to model that real world in order to get the computer to do work on it. So if we're being clear with the computer, what we really should be doing is as accurately as possible, modeling the real world and building our language with the computer, our software, in order to describe that real world accurately. And that's domain-driven design. That's straight up just what domain-driven design is. So when we're on a software team and we're using domain-driven design and we're describing the actual world as accurately as we can, and we've got our Jira tickets and our Kanban boards and our sprint planning and our meetings, and we're all working beautifully asynchronously because this is the future, this is also getting towards a solved problem, more or less. We have, obviously there are still difficulties, but actually, as a profession, as an industry, we are maturing to a point where working in teams is something that's understood and we have good frameworks for it. But I've lied to you again, because this is not actually what's happening when we build software, right? What's happening when you build software as part of a company is that you have stakeholders, and they are the people who pay your bills and tell you what problems you are trying to solve with the computer. And they do this, they say, here is what we're going to build. Here are the requirements for our project, and here's the problem that we're going to try and solve with it. And this can be in the form of talking to product owners, this can be in the form of OKRs, and so on. And those turn into actionable things for you as a developer. They turn into Jira tickets, they turn into epics, and so on. And those let you know what it is that you need to communicate to the computer. So you try and do that. And here, developers is standing in for the whole team. It's not just one person. And this is really what's happening when we build software as part of a company. Right? This is the flow of information. And at every stage, we've got concepts and signifiers and fuzziness going on. And the more we can eliminate that fuzziness by really pinning down what we're talking about, making sure that the rules of the language game we're all playing are actually the same thing. When your stakeholder says user, do they mean person? Do they mean account? do they mean email address? When they say payment, do they mean a payment that can be refunded? Do they mean a single transaction, something that can be reversed or not? What ideas do your stakeholders have about the world? Because once you know what those ideas are, you're going to be much better able to communicate them to the computer. Build up a language with all your house rules, because that's what software is, that will let you talk to the computer about what is going on in the real world. You want your abstractions to be neat and really try and match reality as much as possible. Because this is what's really happening when we build software. But what stakeholders think is happening is this. Your stakeholder has a company, let's say it's the CEO, and they say they have an idea in their head, and they say something, and then software appears. And we as developers, as product owners, as architects, as designers, testers, maintainers, we're just an implementation detail. And our work that lives within this little bubble is everything I've just been talking about. It's the work of taking those real-world problems as our stakeholders understand them and turning them into something that the computer can understand, building up a set of language with which we can talk to our computer and tell it, hey, we need users to be able to change their email address. Because if what your computer understands by user is something that can't possibly have to have its email address changed, then you won't be able to communicate it. When I first gave this talk, it was in Porto. And do we have any Portuguese speakers here? We do, yes! Every time I've said that, that's been one, and I'm so grateful. So the word I used to illustrate this point was saudade. Would you like to give me a translation? Yeah? So my understanding of this word, it's sort of a famous untranslatable word in Portuguese, and it's called, the word is saudade. And my understanding of this word is that it refers to a bittersweet longing of wives whose husbands were out pioneering during the age of sail, or the bittersweet longing of Portuguese people who had gone to Brazil, left behind everything they'd ever known for something new and brave and unknown, a chance at a better life, knowing that they would never again see something with which they were familiar with from back home. And this is often called untranslatable because it relies on a very specific cultural context, and as we know, context gives language meaning. When you have the problem where your stakeholder has said, we need to do this, and you have to rewrite your software from scratch, you have to get rid of all of your house rules and go back to the basics of your framework or your language, that is when you have an untranslatable concept, because your context is not the same, because you've not built the rules of your language game to accommodate that move. So that's why that problem is a failure of communication. And that's the kind of failure of communication that frameworks like ideologies like domain-driven design are aiming to address. Yeah, domain-driven design, it's cool. There's lots of concepts in there that I think will become a lot easier to understand if you're new to it. Having seen this talk, one of the things that gets talked about a lot is the idea of ubiquitous language, which sounds so obvious now, right? The idea that you should have a shared language between you and your stakeholders so that when they say user, you know that what your computer understands by user is actually the same thing, and you're not going to have problems with untranslatable concepts. So, we're getting towards the end of this talk, but I'd like to wrap up with a few thoughts. What this all means in the world of sort of building software is that it's really good to reuse context. If we reuse context, we can make sure that our language means the same thing, because context is what gives language meaning. We want to all be playing the same language game, our stakeholders and our computers. We don't want to have to be doing a lot of work to translate and referee two games at once. We want everybody to be playing together so that all our lives are easier. Exactly, spending effort translating. If we can make it so that essentially we get to the point where our stakeholders are saying things, we can turn around and just kind of say that directly to the computer, our lives are going to be so much easier and we can all have more time to go home and play Baldur's Gate 3 or something. Now, this is where the idea of having stakeholders write behavioral tests in language like Gherkin comes from. The idea that your stakeholders, the way that they see the world should be what your computer understands as well. We want our signifiers to match our concepts. We want to make sure that that fuzzy translation layer in each person's head, the loss of nuance and the risk of miscommunication is minimized by really drilling down and saying, okay, what do you mean when you say user? Because I know that that's the signifier that you're using, but what is the concept in your head? Get them to describe it in multiple ways so that you have more chance of understanding what it is they really mean, and you can avoid problems that arise from that lack of understanding. Conclusions. Computers are awesome. We can communicate with them in ways that we can't communicate with people. What I meant when I said computers have no interiority, in contrast to humans, where the pink light bulb and the blue light bulb you can never really know. If you've got code that fits in your head, and you manage to communicate it correctly, adequately to the computer, you can know for a fact that you succeeded in that communication. That feeling of, yes, it works, even if what you're doing is just writing FizzBuzz in a new language. That's an incredible feeling, and it's something you can never quite have with another person because of that lack of ability to compare what's in your heads. I think that's why a lot of us who have struggled with communication in the past, and I certainly have, I'm great at communication now, I've got a system. But I think that's why a lot of us are drawn to computing, is because of that sort of certainty, that ability to define the way that you communicate with another entity, even if it doesn't have interiority. Communication is intrinsically hard. There's no surprise that it's one of the hardest problems we have. Intrinsically, philosophically, it's difficult, and I think we should all be proud of ourselves for managing to do it at all. Also, extra pat on the back for people who are listening to me speak quickly in English, whose first language is not English, which I appreciate is probably most of you. Communication is really, really hard, and we shouldn't be tough on ourselves for finding it hard, because it is. However, we can get better at it. Trying to understand what somebody really means when they use words to try and signify a concept, understanding what somebody else's context may be so you can understand what rules they're playing by when they use language, can make you much more effective as a communicator and as somebody who understands what other people are saying. This will impact your life in any time you have to talk to another person, which is a lot of your time, especially in a profession where a lot of what we're doing is communicating about the problems we're trying to solve with software, putting them on the computer, which is a form of building language, but also in your personal life. It makes it easier just to talk to other people in general. It's one of the things which is, it's really difficult, but it's one of the most rewarding things I think you can do. Thank you so much for coming with me on this journey through philosophy and linguistics. On the screen right now is a little QR code where you can give me feedback if you would like. It's completely anonymous, it's just a free text field. We have time for questions, but otherwise please feel free to go and grab some coffee, grab some food. I know we'll be at the Pokeball stand before long. Thank you very much for your time and attention.